So today we're going to talk about solving compound inequalities. And a compound inequality is just kind of two inequalities mashed together. So instead of writing h greater than or equal to 52 and h greater or less than or equal to 72 as two separate inequalities, sometimes we choose to write them as a compound inequality, and we put h in the middle, so we would say 72 is greater than or equal to h, which is greater than or equal to 52. A compound inequality containing and is only true if both inequalities are true. So if you see the word and, so like this and this is true, it is only true if both of them are true. And when we see the word and, we should be thinking of an intersection. Okay? An intersection is defined as the following: where two inequalities overlap on a graph. Because if we think about this, and I were to graph those two inequalities I had listed before, draw myself a number line. Here's 52. Here's 72. My first one said h is greater than 52, or equal to. So I'm going to use a closed circle, and my line goes this way, right? But my second one said h is less than 72. Again, closed circle, and it goes this way. So the compound inequality is true for this area h in between 52 and 72. So this area where they overlap, that is where my inequality is true. Okay? This is an intersection. It's where those two inequalities overlap on a graph. Okay? The area they share, the area they overlap, that's my intersection. Okay? So let's go ahead and solve and graph an intersection. And we'll do this one together, and then we'll do one on our own. So let's say I have -2 less than or equal to x minus 3 less than 4. Okay? So this time I have this x minus 3, which I kind of have to solve before I can do anything else. So I'm going to go ahead and, instead of working with the compound inequality all at once, I'm going to go ahead and break it down into two different inequalities. So I'm going to break it down into 2 less than or equal to x minus 3 and x minus 3 less than 4. Okay? Then I can manipulate it so I get x by itself. So I can add 3 to both sides. Here I get -1, I'm sorry, not -1, +1. Let me erase that. +1 is less than or equal to x. And over here, when I add 3 to both sides, I get x is less than 7. So again, I can put this back together then. 1 is less than or equal to x less than 7. And when I go to graph this on a number line, here's 1, here's 7. We know that x, there's a closed circle on 1. X is greater than or equal to 1, so the line goes this way. There's an open circle on 7, and we know that x is less than 7, so there's a line this way. So our answer is in this intersection right here. And some of the problems we work may ask you to label this and as an intersection, or the other term we're going to use in a second. And so if you see that they overlap like this, we call it an intersection. If you want to abbreviate that, an intersection, the abbreviation looks like this. Kind of like an N for intersection. Okay? The other type of thing we will see on graphs is called a union. And the abbreviation for that is a horseshoe like this. Looks like a U for union. And a union happens like this. Let's say we have -1 greater than or equal to x greater than 2. Okay? So when I go to graph this on a number line, here's -1, 0, 1, 2. We know we have an open circle on -1 and a closed circle on -1 and an open circle on 2. Got them mixed up for a sec. Okay? And if we broke this down, we would say -1 is greater than or equal to x, or x is less than or equal to -1, and the other part would be x greater than 2. So x less than or equal to -1, my arrow goes this way, and x greater than 2, my arrow goes this way. Notice that the lines do not overlap. Long day. They do not overlap at all. This is where we have a union. Okay? So a compound inequality containing the word or is true if at least one of the inequalities is true. It is the graph of a union with this. So if we see or, think of union. If we see and, think of intersection. Intersection, they overlap, they intersect. A union, they actually go apart from each other. Okay? So let's go ahead and try to solve or graph a union. So we'll have -2m plus 7 less than or equal to 13. And that might be true. Or 5m plus 12 greater than 37 might be true. Okay? So I'm going to solve both and graph them. Notice automatically we see the word or, so I'm already thinking union in my head. I'm going to subtract 7 over here and get -2m less than or equal to 6, divide by -2. Remember, I'm dividing by a negative, so my sign will flip, so I have m greater than or equal to -3. Or, over here, I subtract 12 on both sides. I get 5m greater than 25. I divide both sides by 5, and I get m greater than 5. I'm going to come down here, and I'm going to draw my number line. I don't know why I wasn't doing that to begin with. We'll put -3 on the number line. We'll put 5 on the number line. And 0 somewhere kind of in the middle here. I have a closed circle on 3, or -3, and my arrow goes this way. I have an open circle on 5, and my arrow goes this way. They don't necessarily point opposite from each other, but they don't intersect in the middle either. So this would still be a union. When we write it back as a compound inequality, -3 is less than or equal to m, which is greater than 5. Notice now my arrows kind of point away from each other. Okay? So this would be a solving and graphing a union. Okay? I'm going to give you some examples where you can solve the compound inequality, but also tell me if you think it is a union or if it is an intersection. Okay? Thanks for watching.